Alright, this is chapter 10 in your textbook. This is a pretty hefty chapter. It relies very heavily on factoring. So you want to make sure, again, that you're very strong and confident with factoring before you really dive into chapter 10. I strongly recommend a few sheets of scratch paper for these notes. This will be your factoring workspace. Some students can factor in their head, and that's fine, or can guess and check and not write much down. But if you're factoring using the technique I taught you, you are going to want some extra workspace to do your factoring so it doesn't muddy up the problem that we're looking at. So the first section is about simplifying, multiplying, and dividing rational expressions. This is a longer section, so it will probably be broken down into a couple videos. So it says a rational expression is a fraction. The word rational is another way of saying fraction, with a polynomial as a numerator and or denominator. Sometimes it's just one or the other, sometimes it's both. So we're going to be looking at problems that look pretty complicated because they have polynomials on top and bottom. So to simplify these, we factor out any GCFs from the top or bottom, factor anything we can, either factor by grouping, trinomials and binomials, anything we can factor, we factor. That's what your scratch paper's for. Once we have everything kind of factored out and sorted out, we divide out any polynomial that exactly matches top to bottom and reduce what's left. So let's look at example 1. Example 1, we have x plus 2, the whole thing squared, divided by x squared minus 4. X plus 2, the whole thing squared, is x plus 2 times x plus 2. Just the same binomial twice. X squared minus 4 is what we call the difference of squares. There's not really a shorthand way to write that, difference of squares. And it factors into x plus 2 and x minus 2. So once you have it all factored out, you have all these back-to-back binomials, there's no other GCFs or factoring that can be done. We look and find any polynomial that exactly matches top and bottom and then reduce. So we have an x plus 2 on top, and we have an x plus 2 on bottom. And it's always 1 for 1. I can't cross out 2 on top and just 1 on the bottom. So the x plus 2, one of them on top, divides with one of them on the bottom. Over here we have x plus 2 and x minus 2, which are two totally different binomials, and we cannot divide them off. So that gives us a final answer of x plus 2 over x minus 2. I recommend keeping these in parentheses so that you know that they're binomials and they go together. Your homework does not require parentheses, but I do encourage it to keep your work nice and neat. Alright, same idea with example 2. If you'd like to pause the video and try it yourself, it's very similar to example 1. So here we have a difference of squares on top, so that's going to factor into x plus 3 and x minus 3. On the bottom we have x minus 3 quantity squared, which means we have x minus 3 twice. So again, we're looking for anything that exactly matches top and bottom. Here's an x minus 3 on the top. And either one of these is fine. We can look at this first. X minus 3, and they divide off. But these will stay. So we're left with x plus 3 on top over x minus 3 on the bottom. And again, I recommend leaving the parentheses so that you don't over cancel, which sometimes happens. Let's look at example 3. We just have 2x squared on the top. There's really nothing we can do with that. We have 10x to the third minus 2x squared on the bottom. That's a binomial, but it's not a difference of squares. If you're not really sure what to do with it, if you ever have that moment of, I really don't know what to do, look for a GCF. And that's true throughout any factoring that you're doing. If you're not sure what to do, look for a GCF. So between 10 and 2, I can take out a 2. Between x cubed and x squared, I can take out an x squared, and that leaves me with 5x minus 1. Now, a lot of students are initially tempted to cross out the 2x squareds from the beginning, but remember this binomial is stuck together. It's considered one expression, and we can't individually pick out things to cancel. But once we take out a GCF, look at the difference. Now, that 2x squared is all by itself, and this 2x squared is all by itself. Now those can divide. When there's nothing left on the top or bottom, we put a 1. So your final answer would be 1 over 5x minus 1. You have to have that 1 on top to indicate that the 5x minus 1 is on the bottom. Again, if you'd like to pause the video and try example 4, it's very similar. We just have a single term on top, 5z to the 4th, so it will still be 5z to the 4th. On the bottom I have a binomial, but I'm not sure what to do with it, so I'm going to look for a GCF. I'm not going to cancel these two because this is considered one piece on the bottom. So between 10 and 5 I can take out a 5. Between z to the 5th and z to the 4th I can take out z to the 4th. And that leaves me 2z plus 1. Now that I've taken out 5z to the 4th as a GCF, it stands alone just like the top, and I can divide them off. Anytime I don't have anything left, I put a 1. My final answer will be 1 over 2z plus 1. And again, I recommend leaving parentheses around polynomials so that you don't get a little too crazy with the canceling. Moving on to example 5, this one jumps up in complexity. We have a trinomial on top and a trinomial on the bottom. So we're going to need to factor. So I'm going to bring example 5 down to my scratch paper. You might want to label it example 5. This is from section 10.1 so that you know what you're looking at. We have 9x squared plus 13x plus 4. And I need to get that factored. I look for a GCF. I do not see one, so I'm going to have A, B, and C. I'm going to set up my chart. 9 times 4 is 36, and B is 13. Two numbers that multiply to 36 and add to 13 are 9 and 4. So I have 9x squared plus 9x plus 4x plus 4. I'm going to do my grouping, and I'm moving through this pretty quick because I practiced this all in chapter 9. We have plus 4, and that also leaves x plus 1. So the top factors into 9x plus 4 times x plus 1. Let's do the same thing on the bottom. We have 8x squared plus x minus 7. So let's get the bottom one factored. I do not see a GCF. We have A, B, and C. Set up my little chart. 8 times negative 7 is negative 56. B is positive 1. So I need two numbers that multiply to negative 56 and add to positive 1. That would be 8 and negative 7. So I'm going to have 8x squared plus 8x minus 7x minus 7. Then I'm going to do my grouping. 8x times x plus 1. Here I'm going to take out a minus 1. Minus 7. That's also going to leave me with x plus 1. So the bottom factors into 8x minus 7 times x plus 1. So again, you don't want all this factoring work muddying up your problem. You always want to work it on a separate sheet of paper. You can have as much scratch paper as you want for your exams, so just ask for more and work that you're factoring in a separate workspace. Once you have it all factored out, the hard part's over. We have an x plus 1 on the numerator and an x plus 1 on the denominator. No matter where it ends up, they can still divide off. And you're left with a final answer of 9x plus 4 over 8x minus 7. For example 6, I encourage you to pause the video and try it on your own first, and then play the video back to see how you did. So let's look at example 6. Again, we have trinomials to work with. So we have, you might want to label this example 6 so you can refer back to it. 5x squared plus 13x plus 6. I do not see a GCF, so I've got A, B, and C. I'm going to set up my table. This is 30, this is 13, so 10 and 3. So we have 5x squared plus 10x plus 3x plus 6. Again, if your work does not exactly match mine, as long as you chose 10 and 3, if you did it in the other order, that's fine. Your final answer should be the same. 5x times x plus 2, and then plus 3 times x plus 2. So the top factors into 5x plus 3 times x plus 2. We'll do the same thing on the bottom. 6x squared plus 7x minus 10. I don't see a GCF, so we'll have A, B, and C. We'll set up our table. Negative 60 and positive 7. So that would be positive 12 and negative 5. So 6x squared plus 12x minus 5x minus 10. Cannot see what I'm doing. There we go. And then grouping 6x plus, just kidding, 6x times x plus 2 minus 5 times x plus 2. So the bottom factors into 6x minus 5 times x plus 2. The hard part's over. You look for what matches. You have an x plus 2 on top, x plus 2 on the bottom. Usually at least one something divides off. Coefficients or binomials, usually one thing divides off or more. And you're left with 5x plus 3 on top over 6x minus 5 on the bottom. And you can keep everything in parentheses if you like, or you can drop them when you type in your final answer. So that's what makes Chapter 10 so exhausting, is that you have to take your trinomials out of the problem, get them factored, and then put them back into the problem. It makes it a very time-consuming process. So the homework's a little shorter. There's a few less examples just because that process is so long. Let's look at examples 7 and 8. They look really simple, but they have a little bit of a trick's not a good word, but they are kind of a trick to them. So we have 2 minus x over x minus 2. Notice here that this 2 is positive and this 2 is negative. That x is negative, x is positive. So what we want to do here is I'm going to switch the order of these, keeping the signs the same. So I'm going to do negative x plus 2 over x minus 2. So I like to have variables first and then constants. And so I'm just going to switch the order of those two. From there, I'm going to take out a negative 1 from the top. Taking out a negative 1 is going to leave me positive x minus 2. And then I'll leave the bottom x minus 2. Taking out that negative 1 gives me matching binomials, x minus 2 over x minus 2. So I can divide those off, which gives me a final answer of negative 1. And that does happen sometimes. I just want you to change up the terms, switch them around, take out negatives, and see what happens. So sometimes your answer can be as simple as negative 1. Same idea on example 8. Just have to pay careful attention. I always like to put the x variable first. So I'm going to make that x minus 3. And then you'll see it matches the bottom x minus 3. And if everything divides, So that's the only part of the problem. If they both divide, if you ever end up crossing everything out, the answer is 1. Not 0, but 1. And that does happen sometimes. You get everything factored out, you start dividing things off. Everything divides off. If you have nothing left, your answer is positive 1. Alright, let's move on to multiplication. These look much more involved because there's 2 rational expressions that you're working with. So to multiply rational expressions, you factor out any GCFs from top or bottom. You factor anything that you can, so this is the same process as simplifying. Then you want to divide out any matching polynomials. You want to get it down as simplified as possible. Then at the very end, you'll multiply whatever remains and reduce. So these first 3 steps are the same steps as simplifying. The more simplified you can make it, the easier the problem will be. Once you've followed all your simplifying steps, then you multiply whatever you have left and reduce. So let's look at example 1. I recommend kind of viewing this in 4 pieces. You just want to look at the top of the first one, the bottom of the first one, the top of the second one, and the bottom of the second one. So try to isolate your focus on one piece at a time. I also recommend, especially if you're can't always follow your work, I recommend making kind of an empty template for yourself to where you have a space to write the first rational expression once you've done your simplification and a place to write your second rational expression. So it just kind of helps you keep track of where you are. So if I look at the top of the first one, I see 3n plus 1. There's no GCF, there's no factoring, there's nothing I can do. So I'm just going to leave it 3n plus 1, and I recommend parentheses. The bottom of the first one is just 2n. Once again, nothing I can do there. I'm just going to leave it 2n. The top of the second one is 2n minus 4. So it looks like I can take out a GCF of 2, and I'll be left with n minus 2. The bottom of the second one is a trinomial that looks like it needs to be factored. So again, I recommend doing that on your own space. You can kind of label this one multiplying notes or multiplying rational expressions. So you have 3n squared minus 2n minus 1. So we have A, B, and C. 3 times negative 1 is negative 3, B is negative 2. So negative 3 and positive 1. So minus 3n plus n minus 1. Take out 3n, you're left with n minus 1. There's nothing there, so I'm going to take out a 1. And I'm left with n minus 1. So that factors into 3n plus 1 times n minus 1. So again, that's the hard part. That takes the most work. Sometimes every single piece has to be factored, and you really got a lot of scratch paper, and you have to get it all factored into these back-to-back binomials. Then you kind of go on a hunt for what matches. I have a 3n plus 1 on top and a 3n plus 1 on the bottom, and so I can divide those off. I have a 2 here kind of by itself, nothing being added or subtracted to it. I also have a 2 here that's by itself. It's being multiplied with n, but it's not being added or subtracted. It's adding and subtracting, you have to be careful. But these 2's can also divide off. So that leaves me a final answer of n minus 2 on top over n times n minus 1. And you don't need to multiply that back in, leave it separate. You need to see all your pieces. For what you use this for in college algebra, you have to see all your pieces. So that's how you write your final answer. If you followed that one, I would pause the video and try example 2, see how you do, and then we'll go through that one. Alright, so again, I recommend 4 separate pieces and kind of set yourself up a workspace so you can know where to put things, Keeps your brain a little more organized. So we have 2 plus 5x on top. There's nothing I can do there, just 2 plus 5x. 3x on the bottom. Then we have 6x plus 3 on top. I can at least take out a 3. That leaves me 2x plus 1. And then on the bottom of the second one, looks like I'm going to have to factor that thing, so I'm going to bring it to my scratch paper. 5x squared minus 3x minus 2. So I'm going to bring that to my scratch paper and get it factored. Five times negative 2 is negative 10. B is negative 3. So that would be negative 5 and positive 2. So 5x squared minus 5x plus 2x minus 2. Look at the first two terms. I'll take out a 5x. That'll leave me with x minus 1. And then I'll take out a 2. That will also leave me with x minus 1. So the bottom of that one factors into 5x plus 2 times x minus 1. Then we go on a hunt for things that match. So we have 2 plus 5x, both positive, and 5x plus 2, both positive. So because everything is positive, they match, even though they're in the other order. When it comes to adding, order doesn't matter. When it comes to subtracting, you have to be much more careful. And we have a 3 on top without being added or subtracted to anything, and a 3 on the bottom without adding or subtracting. So this 3's can divide off. So similar to the first example, you're left with 2x plus 1 on top, and an x by itself with an x minus 1 on the bottom. And you can just leave your answer just like that. Don't multiply anything back together, and don't cancel more. Do your factoring, do your dividing or canceling, and then be done. Don't go crazy with the canceling. I'm going to pause there, and then I'll do the next two examples on the next video.